Learn chapter. Hello students, welcome back to the channel. Today we are going to learn chapter number 4, structure of atom from the NCERT class 9 science textbook. This chapter explains how scientists discovered the structure of atoms, the basic building blocks of matter. I will explain the full chapter in very simple language, the same style used in NCERT, and I will also give an important exam question at the end. Okay? So let's start. In this chapter, we discuss early modes of atoms, Thomson's model, Rutherford's alpha particle scattering experiments, Bohr's model, what are shells or orbits, what are valency, atomic number or mass number, how to calculate number of protons, electrons and neutrons, isotopes and isobars, and some importance formula and some ancient style questions also. Okay, these notes are short, simple and perfect for a revision. So let's start. First of all, we discuss charged particle in a matter. Atom have three types of subatomic particles. They are electron, protons and neutrons. Electrons are negatively charged and positively charged P+. Neutrons have a no charge. The mass of an electron has a 1 by 2000 the mass of the hydrogen atom. The mass of proton is equal to the mass of hydrogen atom and is taken as 1 unit. The mass of neutron is equal to the mass of hydrogen atom and is taken as a 1 unit. Okay. First of all, we discuss discovery of subatomic particles. In 19th century, J.J. Thomson discovered the presence of the negativity charged particle, it's called a neutron, in the atom. In 1886, E. Goldstein discovered new radiation in a gas discharge and called them canal rays. These rays were positively charged. This latter led to the discovery of the positively charged particle called proton in the atom. And last, in 1932, Chadwick discovered the presence of the particle having no charge in the atom is called neutrons. So, this all are very important for MCQ and questions. So, quick remember. Let's start structure of the atom. First, we discuss Thomson model of atom. According to Thomson, an atom is similar to Christmas pudding. The pudding had a positive charge and the electron having a negative charge. Well, like proposed that an atom consists of the positively charged sphere and the electron are embedded in it. Okay, you can see the are equal in a magnitude, so the atom as a whole is electrically neutral. Okay, simple but easy. Okay, next we discuss Rutherford's model. There's gold foil experiment also called. Rutherford fired alpha particles at a thin gold foil. In the observation, most particles passed straight, meaning atoms has an empty space. Some deflected, meaning atom has a positive charge at a center. And third, very few bounded back, means center is very dense. Okay, and its conclusion is atom has a small dense nucleus, electrons revolve around the nucleus, and most of atom is empty. Okay, this recall its experiment conclusion and Rutherford model of an atom. Okay, you can see this is defect of the Rutherford model of the atom. Any particle in a circular orbit would be undergo accelerated, and during acceleration the charged particle would radiate to energy. So the revolving electron would lose energy and fall into the nucleus, and the atom would be unstable. We know that atoms are stable. So this is defect. Okay, you can remember with diagram. This is important for exam and remember also. Okay. Next we discuss Bohr's model. Bohr improved Rutherford's model. How? He said electrons revolve in fixed orbits. It's called cell K, L, M, and N. Each orbit has a fixed energy. Electrons do not lose energy while revolving. He said electrons move to higher or lower shells by absorbing or releasing energy. This point are very important to remember this. Okay. Next, distribution of electron in difficult shells. You know that here we use a 2n square. Okay, here n is equal to 1, 2, 3. K shell has a 2 electron, L shell has a 8 electron, M shell has a 18 electron, and N shell have a 32 electron. Okay, and the maximum number of electrons that can be filled in a outermost shell is 8. Okay, an electron cannot be filled in a shell unless the inner shells are filled. Okay, some important terms we can use, and this all the your textbook table. You can remember hydrogen to chlorine. Okay, short form is highly beboka, now for nisomesi for saka. Okay, this is short key for we can use hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. Okay, and symbol also learn it, and its electron fulfilling diagram also you see. Here hydrogen has a 1, helium, and then lithium has a second shell. Okay, lithium to neon has a second, and the sodium to argon is the third shell. You can remember and recall this. Next, valency. First of all, valency combining capacity of atom. For example, sodium valency is 1. Okay, why? The electron present in the outermost shell of the atom is called a valency electron. If an atom's outermost shell is completely filled, so they are inert gas, and their reactive or their combining capacity or then valency is also 0. All inert element has like a helium, neon, or argon, etc. For example, helium atom has a 2 electron in the outermost shell, and the atom of other elements have 8 electrons in their outermost shell. Atoms having 8 electron in their outermost shell is having a octet configuration, and they are stable. Okay, if atom's outermost shell is not completely filled, okay, so it will be not stable. It is not stable. It will be try to attain stability by losing or gain or sharing electron with other atoms to attain octet configuration. The number of electron lost, gain, or shared by an atom to attain the octet configuration is the combining capacity or a valency of the electron. For example, hydrogen, lithium, sodium atoms can easily lose 1 electron, become too stable, so their valency is 1. Here magnesium can easily lose 2 electrons, so its valency is 2. Aluminium can easily lose their 3 electrons, so the aluminium has a 3 valency. You can see in this figure. Okay, and remember, fluorine can easily gain 1 electron to become a stable, so its valency is 1. Oxygen can easily gain 2 electron, so its valency is 2. Okay, you can listen and figure out. To nitrogen can easily gain 3 electrons, so its valency is 3. Okay. Next important terms. First is atomic number, that's Z. Number of protons. Here are protons equal to electrons in the neutral atom. Okay. What is atomic number? The atomic number of an element is the number of protons present in the nucleus of the atom of the elements. You can see here hydrogen, helium, lithium all are one atomic number, so it has one proton or electron also. Lithium has 3 proton or 3 electron, so its atomic number is 3. Next, mass number is denoted by A. A is equal to number of proton plus number of neutron, not electron. You can remember this. Mass number is equal to number of proton plus number of neutron. Okay. Carbon, the mass number of an element is 12 because it has a 6 proton or a 6 neutron. So its mass is 12 unit. Okay. Aluminium mass number has a 27 because 13 proton plus 14 neutron. Sulfur mass number is 32, 16 proton plus 16 neutrons. Okay, you can remember this symbol of elements. We can write down the left top of mass number and left bottom of atomic number. Okay, you can example see the 14 and 7. Okay. Next, we will discuss two isotopes. What is isotopes? You can remember? Atom of the same element, same atomic number but different mass number. Suppose example hydrogen has a 3 isotopes. 1 has a proton, 2 has a deuterium and 3 has a tritium. Here all the same elements, same atomic number but different mass number because of its neutron. Okay, protium has a 1 neutron and 1 proton. Deuterium has a 2 neutron and 1 proton. Tritium has a 3 neutron and 1 proton. Okay, carbon isotopes is carbon 12, carbon 14. Chlorine has a 2 isotopes. They are 35 chlorine and 37 chlorine. Okay, you can remember same element, same atomic number but different mass number because of our mass number. So next we will discuss isobars, atom of different elements with the same mass number but different atomic mass. Okay, isobars means isobars are atoms of different elements having a different atomic numbers but same mass number. This pair of elements have the same number of electrons. For example, calcium has the atomic number is 20, argon atomic number has 18, have a different atomic number but have the same mass number is 40. Because of their neutrons are variable. Iron and nickel have a different atomic number but have a same atomic mass number, that is 58. Just because of their neutron counting is different. So in this total of atomic mass are same Fe and nickel also. Okay, how to use PDF for this exam? Student, study this PDF daily. Like this you can learn all the definition by heart, practice Bohr models diagram, remember all formulas, do NCERT in text questions, revise structure of atom for each element given in examples. If you revise this PDF 2 or 3 times, you will score full marks in this chapter. I guarantee. I can include the question, some important questions, MCQ below in the link. You can see, okay, and answer it. So, student, this was a complete and easy explanation for chapter 4, structure of the atom, for the NCERT science textbook for class 9. Download the notes PDF from the link, revise the important questions, and you will be fully prepared for your exam. If this video helped you, don't forget to like, share and subscribe. Thank you for watching.